All right, finally, we're going to take a look at dependent samples t-test. All right, in dependent samples t-test, we're using, we're making a slightly different comparison. So, what is a dependent samples t-test? Dependent samples t-test determines whether there is a statistically significant difference between paired observations from the same subjects. It's used when you want to compare measurements from the same individuals at different times or under different conditions. So, dependent samples t-test can control for individual differences by having subjects serve as their own control group. So, just to reiterate, one sample t-test compares a sample to a population. Independent samples t-test is comparing two unrelated groups to one another. Dependent samples is comparing the same group at two different points in time. So let's take a look at an example of dependent samples t-test, specifically using cognitive behavioral therapy. So a psychologist wants to determine if cognitive behavioral therapy, CBT, can help reduce anxiety in community college students. Turning this into a research question, does an 8-week CBT program reduce anxiety symptoms in community college students with diagnosed anxiety disorders? This the So we still want to learn how to identify independent and dependent variables. The independent variable for a dependent samples t-test looks slightly different, because instead of thinking about one sample compared to a population, or instead of thinking about two groups compared to one another, in this case we have to kind of think of it as before and after, right? And that's where I use that language. An alternative way to identify a dependent samples t-test is to call it a paired samples or before after t-test. And that's because your independent variable is looking at the same group of people at one point in time and then again at another point in time. In this particular example, we're talking about assessing our participants before they start the 8-week CBT program and then assessing them again when they've completed the 8-week CBT program. Our dependent variable in this case is going to be anxiety levels. We are going to capture their anxiety levels at time 1 and then compare them to anxiety levels at time 2, before and after attending this 8-week CBT program. Okay, yeah, so this last point is what I've been describing about 2 points in time, before and after. So study design, hypothesis, and alpha level. So the researcher selects 32 students with anxiety disorders who receive 8 weeks of, oh, excuse me. Oh, sorry about that. Who receive 8 weeks of cognitive behavioral therapy. Anxiety levels are measured on a standardized scale from 0 to 40, where higher scores equal more anxiety. Then instead of having, men versus women or just one sample of data, we are going to identify a pre-treatment or a before time sample data, and then after time post-treatment sample data. So our anxiety levels pre-treatment, before attending this CBT program, were 28.6 with a standard deviation of 5.3. Our post-treatment averages for anxiety levels, so after attending the CBT program, were 21.2 with a standard deviation of 6.1. We also have to incorporate some additional information, because now instead of talking about comparing two unrelated groups, we have to talk about the difference between time 1 and time 2. So we incorporate this notation of mean difference, which is 7.4, suggesting a reduction in anxiety, as we can see from their pre-treatment anxiety levels when compared to their post-treatment anxiety levels. We have a standard deviation of differences of 4.8. Okay. All right, so our null hypothesis, null in research for this particular scenario, we have that the population mean is going to be 0. In this case, a 0 indicates that there's no significant difference in anxiety before and after CBT. Our research hypothesis suggests that our population mean is not equal to 0, therefore suggesting there is a significant difference in anxiety before and after CBT. We see that literally there's a difference. 28.6 is not the same same as 21.2, but we want to know whether that difference is statistically significant. Again, I'm setting your alpha level 0.05. All right, so how do we calculate in a dependent samples t-test? Same kind of overarching process where we're calculating t-ratio, degrees of freedom, identifying critical t-ratio, comparing them to one another. Based on the prompt, we know that we have an N of 32. We have 32 people who participated in this study. Our pre-treatment values were a mean of 28.6, standard deviation 5.3. Post-treatment was 21.2, mean 21.2, standard deviation 6.1. The mean difference was 7.4. It's a reduction in anxiety based on the differences between pre and post treatment. This is calculated by adding up all the individual differences in scores and dividing by the numbers of pairs. So what this would look like in practice is saying, all right, for participant number 1, their pre-treatment anxiety was 32, their post-treatment anxiety was 30, okay? For participant number 2, their pre-treatment was 40, their post-treatment was 28. And then we would calculate a difference. What is participant 1's 32 minus 30? What is participant 2's 40 minus 28? And whatever those scores are, we would add them all together and divide by how many pairs there are. That's technically how, well, I don't want to say technically, that is how we calculate the average difference. We would also calculate what's called the standard deviation of differences. We're not looking for an unbiased estimate of a single standard deviation. We're looking at the differences between the standard deviation of pre-treatment compared to the standard deviation of post-treatment. So this is calculated by adding up all the squared deviations, dividing by n-1, and taking the square root. This is essentially what the formula looks like. I didn't want to get into the thick of calculating this because, again, we're not going to be doing this by hand, but I do want you to understand how it works. We would then calculate what's called our standard error, which is identified as this lowercase s. We've seen this before. Before we saw the standard error of the mean of a sample as the x bar. In this case, we're looking at the standard error of the differences. So we would take our standard deviation of differences divided by a square root of n, with our t-ratio now also being modified, where we would take the mean differences divided by that standard error, and we're back to a degrees of freedom of n-1. If we were to do all the math on this, we would calculate, so we would calculate a standard error. This actually should be, that's a mistake on my part. This should be not s over x. Can't believe I just wrote another x on top of that. This should be s over mean differences, which means this should also be s over mean differences, is equal to 0.85. There's a calculated t-ratio of 8.71, degrees of freedom of 31. If we take our degrees of freedom and our alpha level, we have degrees of freedom 31, alpha level 0.05, take it over to table C, look at where those 2 points intersect, we would find that the critical T is 2.04. T of our calculated T of 8.71 is further than 0 from a critical T of 2.04. Therefore, we reject the null hypothesis. As you can expect, I'm going to show you reporting results for dependent or paired samples. So paired, I think, is probably a little more common than the other alternatives that I showed you at the start of this presentation. And so we would write a paired samples t-test was used to evaluate the effect of an 8-week CBT program on anxiety levels in college students. Results revealed a significant reduction. Remember, the reduction is determined by seeing the difference between the pre-treatment and post-treatment anxiety levels. In anxiety scores from pre-treatment with a mean of 28.6, standard deviation 5.3, to post-treatment with a mean of 21.2, standard deviation 6.1. Then we have our formula, if you will, of T of degrees of freedom 31, calculated T 8.71, with a P of lower than 0.001. Really, I should have included, because I plugged a couple of these things into SPSS. So really, this should say 0.05 because I didn't change the alpha level. So the mean decrease in anxiety scores was 7.4 points with a standard deviation of 4.8, standard deviation of differences of 4.8. indicating that the CBT intervention was effective in reducing anxiety symptoms among the participating college students. Remember that this is our mean difference. Okay. Okay. So, interpretations and implications. Bringing in this interpretation, since 8.71 is further from 0, larger than 2.04, we reject the null hypothesis, conclude that the CBT program significantly reduced anxiety symptoms. What are some implications for this? We could gauge that CBT is effective for reducing anxiety in college students, which is an important thing to know and be able to implement. The treatment effect is strong, and we understand strong. We haven't got into what's called correlations to understand a little bit about the relationship of strength. But we can see that this 8.71 is significantly different than the critical value and so by the high T ratio, we see that the effect is strong. The individual treatment responses could be further analyzed to identify factors affecting treatment success. Maybe there were, although on average there was a reduction in anxiety levels, maybe if we looked at the individual data, we might see that some participants saw increases in anxiety level, after treatment, right? So are there other things happening outside of the treatment that are contributing to their anxiety levels that we're not accounting for? And so that was all I got for these implications, or all I thought of. So those are the 3 types of t-tests that we're going to be using in SPSS when we start the next SPSS module, if you will. And so remember that this is all about t-tests. We learned about one sample, independent samples, and dependent samples t-test, and we were able to see how to calculate and how to report on results. And that's a really important piece. I am going to be asking you to put the reporting results piece into action, or into practice rather, with your learning check. So you want to make sure that you understand the kind of overarching structure or outline for the reporting results, and then thinking about it like a formula. If you think about it like a formula, it might be easier for you to piece the things together that you need to make sure you include. Okay. All right. As always, if y'all got any questions, you know where to find me.